lesson 1.5, infinite geometric series. I wanted to talk about the idea of convergent versus divergent. Just a new piece of vocabulary. Convergent means heading towards something, divergent means heading away in just regular English. And so the question is, do we have an infinite sum or not? So if you have a sum and you can find it, that series is convergent. If your answer is just getting bigger, bigger, smaller, and smaller, not heading towards any value at all, it's divergent. And it comes down to a very simple test. So we have two series here, both geometric. So 4 plus 8 plus 16, very simple geometric series, has a common ratio of 2. This other one, 15 plus 5 plus 5/3, also geometric, this time has a common ratio of 1/3. The key condition is the common ratio between -1 and 1? Clearly, 2 is not. And so that means right away, no. This series is divergent. It means no, I cannot find an infinite sum. It means if I kept trying to add terms over and over and over in that series, I wouldn't head towards anything. I'd just keep adding bigger and bigger numbers, so I'd be going infinitely large. This other series is different though, because the ratio is 1/3. It means these numbers are shrinking. So is that ratio between -1 and 1? Yes, it is, which means this is a convergent infinite geometric series. Convergent meaning can I find S infinity? Sure. And my formula sheet has a surprisingly simple formula for S infinity. And I substitute in the term 1 and the ratio, and I get an answer of 22.5. What does that mean? It means if I took the terms in this series and added up not just those first 3, but kept going and adding in the next one, the next one, the next one, the next one, I could keep adding those forever, and I would just keep getting closer and closer and closer to an actual answer of 22.5. And it makes sense, again, because you're adding smaller and smaller numbers, they're not changing the overall total in the same way that adding bigger and bigger numbers would, explode. You're just heading towards infinity. So the difference between divergent, if the ratio is not between -1 and 1, and convergent, if the ratio is between -1 and 1. If it's convergent, that's the only time you can use this formula. If you tried using this S infinity formula for this series over here, you'd get a very nonsense type of answer, because you'd have 4 divided by 1 minus 2, which would not mean anything in terms of that actual series. It's not the infinite sum, because there isn't an infinite sum.